All right, so today we took notes on finding area of triangles. For area of triangles, this is always going to be base times height and then divided by 2. There are a few ways this formula has been written and can be written. We can have the standard area equals base times height divided by 2, or area equals 1/2 of the base times the height, or area equals the height times the base multiplied by 1/2, or the base times 1/2 of the height, or the base divided by 2 times the height. Any combination of these. We can manipulate any one of these two equations as long as we are dividing by 2 or multiplying by 1/2 at some point, and at some point we are multiplying the base and the height. That's the general takeaway, but our main focus is going to be on this expression. Or this equation. This is going to be the primary equation and formula we use for finding area of triangles. Now, an important note when finding area of triangles and area of anything is never, ever, ever use diagonals for area. Ever. There will not be a single time we will ever use diagonals to find area. It is not going to give us an accurate height or base. Instead, what I want you to do when you are finding area is to look for the right angle symbol. That is going to be your hint for how to find the accurate base and height of almost all shapes. And then we're going to do 4 examples. We did 4 together in class, so we're going to do 4 now. The first 2 would be a right triangle and an obtuse triangle. Now the right triangle, pretty easy to tell the base height and the diagonal because our right angle is right here. It's always given to us. And we can see that our diagonal is going to be this 12 inches. Now we just take our base and height, so 8 times 5, which would be 40, and divide that by 2, which gives me 20 inches squared. That's going to be number 1. Our second example was an obtuse triangle. Now, obtuse triangles oftentimes are going to have a height line. These are just lines drawn off to the side that tell us what the height is. Technically, this would be our height line for number 1, but we don't usually have to draw an additional line for that. Over here, same thing. We can see our right angle symbol. We can see that this must be our height and this must be our base. So 6 times 3, which would be 18. 18 then divided by 2 gives me 9 meters squared. Again, our diagonal is pretty easy to tell. I'm going to intentionally move the camera off to the side so you can't see number 4 yet. But for number 3, we have a standard isosceles triangle, but and an equilateral triangle would be drawn very much the same way. For this shape, we can cross out 2 sides because we have 2 diagonal sides for this, and our height line is actually going to be inside of the triangle. So we get 8 meters by 8 meters. 8 times 8 divided by 2 would give me 32 meters squared. Now, our last shape is another right triangle, but it's been rotated. Oftentimes, I'll show students this shape, and they will think, oh, well, the height must be down here. The base is down here, and there's no height. Mr. Altamir lied to me. There's no height. No, I didn't. That 12 is the diagonal line. This is just a right triangle that has been rotated. If I were to rotate this camera a little bit and flip it over, covering the camera. If I flip the camera over, you'll see, oh, it is a right triangle. Whoops. So yeah, be very careful. That is something that can happen. As a matter of fact, number 4, this problem right here, is literally just the first example, only rotated. That's all this is. I use the same angles and same measurements and everything. 5 for the short length, 8 for the long length, and 12 for the diagonal. This is the same. All I did was I rotated it. But it is a right triangle. It's just been turned to try to trick you. If I am going to give you a quiz on finding area of triangles, and you know that I will, that is the sort of problem I would give you to make sure that you are paying attention in class. But other than that, we didn't do anything else for notes. We just focused on those 4 examples and our main definitions and hints to look for the right angle and to make sure that we are paying attention if the shape has been rotated. And that's it. Remember, this is a calculator active unit. You do not have to do all of this in your head. You do not have to do all this by paper, particularly when we get to things with decimals and fractions. Doing it without a calculator is beyond the 6th or even the 7th grade level. So don't worry about doing that. Use a calculator. That's it. Good luck.